In Module 7, Lesson 4, we talk about simplifying square roots. So simplifying means we want to break things down, but we don't need to necessarily evaluate it. And what we're going to see, the reason for simplifying square roots is that when we try to evaluate some of these, we're going to get what's called an irrational number. It's going to be a decimal that goes on and on forever, doesn't stop, doesn't repeat. Okay, so let's review our understanding of square roots. So what does the square root of 16 mean? Well, keeping in mind that there's that radical sign there, so we're looking for a positive square root. And we're looking for what number times itself equals 16. And we know that to be 4, because 4 times 4 is 16. Well, what does 4 times 4 equal? Well, 4 times 4 is 16. That goes along right there. So does the square root of 16 equal the square root of 4 times 4? And the answer is yes. Okay, so the square root of 16 is 4. 4 times 4 is 16. So this is like saying the square root of 16. So yes, they're the same thing. Now, the next part here gets into why perfect squares are important. It says rewrite the square root of 20 using at least one perfect square. So let's talk about what our perfect squares are. So perfect squares are numbers like 16, because if we take the square root of 16, we get 4. Or we can think of it as 4 times 4 equals 16. So I'm going to look at it from that end. 1 times 1 equals 1, so 1 is a perfect square. 2 times 2, or 2 squared, is 4, perfect square. 3 times 3 is 9, perfect square. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. And you can see that you can keep going. These right here are perfect square numbers, or perfect squares. Because if I take the square root of 1, I get 1. If I take the square root of 4, I get 2. If I take the square root of 9, I get 3. I take the square root of 16, I get 4. So if it wants us to rewrite the square root of 20 using one perfect square, what I can do is I can break down 20 into 2 factors. Equal sign there. And I'm going to multiply them. So what two numbers times themselves equals 20? At least one of them being a perfect square. So if I look at my perfect squares here, which one of these numbers goes into 20? 4. So we can rewrite this as 4 times 5. Just like up here, the square root of 16 equals the square root of 4 times 4. The square root of 20 is going to equal the square root of 4 times 5, because 4 times 5 equals 20. Let's do the same thing here for the square root of 28. Using at least one perfect square, what two numbers can I multiply together to give me 28? Well, if you look at your list of perfect squares, I again would say 4. 4 times 7. Now, why is that important that we can pull out perfect squares? And that's what comes down to simplifying. Simplifying the square root. The reason we simplify is because if I were to do the square root of 50, I would get, well, the simplified answer here, 5 times the square root of 2. But I would get a decimal, if the calculator didn't simplify it, that goes on and on forever. It stops at 2 here only because the calculator ran out of room. So this is not an exact answer. We're going to have to approximate this. This is an exact answer. In fact, if I go 5 times the square root of 2, you're going to see I get the same thing. So how do we get that 5 times the square root of 2? And what you do is you rewrite it using at least one perfect square. So if we look at the square root of 50, I can come over here to my perfect squares, keeping in mind that they continue. Which one of these numbers goes into 50? And sometimes you're going to find more than one. Knowing my factors of 50, I know 25 goes into 50. So I can take the square root of 50 and I can rewrite it as 25 times 2. 25 times 2 is 50. I can break this up then into factors. I can rewrite the square root of 25 times 2 as the square root of 25 times the square root of 2. And then, if I had just given you that problem, what is the square root of 25? You would say 5. What is the square root of 2? Well, you want to try it on your calculator. You'll notice it doesn't give you anything. Whoops. Well, let me try that again. It's because it's an irrational number. It's a non-terminating, non-repeating decimal. So we're going to leave it as the square root of 2. And that's how you simplify it. I do have one more way, and I'm going to show you both ways. This one gets there a little bit quicker, but the next way might help you if you're not quite understanding how to come up with the perfect squares, and it helps when the numbers get bigger. It goes back to factor trees. Long ago, you had to do factor trees with numbers. So if I want to do a factor tree of 50, I can break 50 down into 5 times 10. 5 is a prime number, and I can break 10 down into 2 times 5. Prime number, prime number. So what you do then is you write them in order, all the factors in order, and you look for doubles. Here's what I mean. Basically what I'm doing here is I'm taking the square root of both of these. Where you see a double, this is like saying it's a square root of 5 times 5. We'll come up here. 4 times 4 is equal to 16, right? So what is the square root of 16? It's 4. 5 times 5 is 25. What's the square root of 25? It's just 5. And so I'm actually going to end up skipping this step later on. But I have to bring the 2 all the way down under the square root because it's not 2 of them. And proper way to write this becomes 5 times the square root of 2. So if that was confusing, and this was confusing, or they both were confusing, we're going to go over some more examples in the next video. But what this is doing is this total focus is on simplifying these where we don't have to put an approximate sign just by typing it into our calculator.